Hi, good morning. Welcome to the video lesson. And today we are going to discuss about certain prerequisite, right? That that is connected with that interpolation, and it is connected with the next lesson, raster analysis, right? Then the terrain analysis, how that one, and that it's a bridge course, and it is a bridge lesson that is not exactly connected with the GIS. Certain terminology explaining certain terminology that is DEM, slope, aspect, viewshed, raster calculator. Uh, See, you know that we have gone through the lesson interpolation, so many things, certain terminologies in that one, certain interpolation techniques, basically the terrain, interpolating the terrain, interpolating certain climatical aspects, interpolating certain rainfall aspects, like different tools, how to use these different tools for extracting results from vector or raster data. So the next class, that's about raster analysis, how to generate or how to analyze certain raster data set for that uh, certain output. So the input is raster, a geo-referenced raster. You know that what you mean by geo-referencing or geocoding. A geo-referenced data set. We will insert certain geo-referenced data set, raster data set, and generating certain result. So in that prerequisite video, we people are discussing about DEM, slope, aspect, view shape, raster calculator. And the next video, we people are discussing about that how to generate certain results, that theoretical aspects. So again, that repeating the same sentence, geography, geography people are studying about the process pattern and behavior. What kinds of behavior? That spatial process, spatial pattern, and spatial behavior. And see, it is that today's lesson, it is bit more relevant. Fine. So kindly watch the video lesson. Wait, post your feedback, uh, properly attend the assessment. We people are checking the assessment. Okay, so welcome to my lesson, video lesson. So what do you mean by a DEM? The abbreviation, that is digital elevation model, is a 3D computer graphics representation of elevation data to represent terrain, commonly of a planet, example, moon or asteroid. A global DEM refers to a discrete global grid. So it is a DEM, right? Digital elevation model. See, this DEM, it is something nowadays you can download it is freely. There are two options, that is um, alloplacer, alloplacer, fine. Alaskan satellite ASF, Alaskan satellite facility. You can download this DEM, digital elevation model, that is nearly 10, no, 12-meter resolution, and you can download Amsterdam from that USGS, United States Geological Survey website. See, the relevance, it is that high importance in case of this GIS studies. It is DEM is very important for studying about so many aspects that is connected with um soil erosion, landslide study, flood prediction, flood related study, so many things. You can predict certain landslides. You can predict certain landslide prone area, right? and it is also connected with certain land use land cover. It is also somewhat similar to satellite image, but the resolution is something different. You have to download certain images, DEM images, and you can process with the help of whether it is a commercial or non-commercial software, with the help of a that system, software, hardware, and remaining. Very, very important. See, remember that very important for studying about landslide, flood prediction, flood prone area, landslide prone area, like that kinds of geographical studies. Them data is very much important, and if you are interested to understand more about DEM, kindly watch one of my video, one or I think two or three parts video, that is types of satellite images, that is for MSc students. You can see that video in that what in that yes, types of satellite image. You can watch that video, and I have explained about what you mean by aster DEM. It's a type of satellite image. Fine. So remember, very relevant one, digital elevation model. Next one is slope. The theoretical, say, I am explaining the theoretical aspect of slope. So the definition, a slope is the rise or fall of the land surface. It is important for the farmer or irrigator to identify the slope on the land. A slope is easily recognized in a hilly area, horizontal, that see in that measurement 0 to 2 degree, steep more than 2.5 degree, and flat 0.0 0.5 to 1 degree. Fine. We will calculate this slope in degrees. I think you people have done the slope calculation, and there are slope and elevation that is connected, and different types of slopes are there: gentle, steep, concave, convex slope. I think already drawn with the help of contour in the practical report. Elevation and slope are the two elements that determine how landform physically appear and connects. Anyway, connect elevation. The contour interval, the elevation between contours, is the vertical distance between adjacent contour lines. On 1 is to 25,000 maps usually used by bushwalkers, contours are either 10 or 20-meter apart. Right? And here is the representation of contour, and different types of slope. Gentle contour lines showing a uniform gentle slope will be eventually spaced and wide apart, easy walking. See? It is a gentle slope, how the contour line and how that slope is. And next one is steep slope. It is steepness. Contour line showing a uniform steep slope on a map will evenly spaced but close together, very challenging or impossible walking. Contour lines may be so close that they create an impossible cliff line. So this is a steep slope. And next one is concave. Contour lines showing a concave slope on a map will be closely spaced. At the top of the terrain feature and widely spaced at the bottom. Bushwalkers going up the slope will find the terrain increasingly steep and challenging. Bushwalkers is something, a try, just giving an example. See, it is the concave slope. And next one is convex. Contour lines showing a convex slope on a map will be widely spaced at the top and closely spaced at the bottom. Bushwalkers going down the slope cannot observe most of the slope on or the terrain at the bottom. So extra care must be taken when route finding. See, it is a convex. It's a bit bulgy. Fine. It's a convex slope. Fine. So we discussed about DEM and discussed about slope. And see, the next class actually I said it is a prerequisite lesson for next class for raster analysis. We people are generating based on DEM data, certain the slope, aspect, and all those things. Aspect is the compass direction that slope faces. It is also known as exposure. The term aspect can also be used to describe the shape or alignment of a coastline. Here, the aspect is the direction which the coastline is facing towards the sea. See here, see these kinds of map we can generate. See, you can see that the different color represent different slope representation. That faces flat, north facing slope, northeast, east, southeast, south, southwest, west, northwest, likewise north. These kinds of the slope facing the in which direction, that is connected with aspect. So one more map, another map. It is all are connected with a DEM. We are generating these kinds of slope, aspect ratio, likewise. And next one is viewshed. A viewshed is the geographical area that is visible from a location. It includes all surrounding points that are in line of sight with the location and excludes points that are beyond the horizon or obstacled by terrain and other features. Example, building, trees. It is a graphical representation of viewshed. Right? Next one is watershed delineation. These all are generating with the help of DEM. All watershed delineation means is that you are drawing lines on a map to identify watershed boundaries. These are typically drawn on topographic maps using information from contour lines. Contour lines are lines of equal elevation. So any point along a given contour line is the same elevation. So this is a watershed delineated in a DEM. And the next class we will discussing about that certain tool sets, something flow direction, likewise. And it is also one more pictorial representation of watershed. And the next concept is raster calculator tool allows you to create and execute map algebra expression in a tool. Like other geoprocessing tools, the raster calculator tool can be used in model builder, allowing the power of map algebra to more easily integrate into your workflows. So this tool, it is actually ArcMaps raster calculator. You can use these tools to generate certain certain image outputs. Fine. It's telling again. It's a prerequisite for coming lesson, and these are the concepts we have discussed: slope, aspect, DEM, types of slope, viewshed, watershed delineation, and raster calculator. So thank you. Thanks for watching the lesson. Kindly attend the assessment regularly. Few people are regularly attending, few people are not attending the assessment. It is not a good trend. Kindly attend the lessons. Attend, see the video lessons and attend the assessment regularly. So thanks for watching. Thank you. Thanks a lot.